Hello, everybody. Thank you for joining us today. Welcome to the talk You Ride It with Spring, You Test It with Spring. My name is Alina, and I'm going to moderate this session. And I'm so glad to introduce you the speaker, Alexander Bermin, lead software engineer in EPAM with more than 10 years' experience in Java development. And before we start, just a quick note the session will be recorded, and if you have any questions regarding the talk, please post them into the chat, and we will discuss them later during the Q&A session right after the session. So we are good to go. Alexander, hands over to you.
Yeah, thank you very much, Elena. Hello, dear friends. I'm happy you've joined my session, and today we will talk about testing of applications written with the Spring Framework using the Spring Framework. First of all, I'd like to introduce myself. My name is Alexander Barmin, and I'm a lead software engineer at EPAM Russia, and today I'm broadcasting from my home online. Besides participation in the projects of our customers, I also play a role of mentor at EPAM Training Center. EPAM Training Center is a great place for innovation and professional growth. My contacts are on the slide, so feel free to reach me by email or on Twitter. I'll be happy to answer your questions. As ordinary, I'd like to start with an agenda. First of all, I will talk about importance of testing as a part of the software development process. Next, I will proceed to the main part of my topic and start talking about Spring's features for testing. We'll talk about configuration of the application context and test layers. Of course, I will show a lot of code examples because it is not really interesting showing code on the slides only. Okay, so we are done with all the necessary preparations and can finally proceed to the main part. So, ready, steady, go! First of all, let me talk a little bit about testing in common. So, the testing is a process that allow checking that a particular unit uh, is working as expected. In this context, a unit can be as small as a particular class and as big as the whole application. One single check is a test case, and test cases are ordinarily grouped together into the test suite. Automated tests are usually written using a testing framework. For example, we have JUnit. JUnit is one of the most popular testing framework for Java. So the test runner executes a test class that have one or more test methods. And ordinary every test and every single test method have the following phases. First of all, it is a setup phase. During this phase, test runner initializes the test fixture, which includes system under test and its dependencies. Also, it brings it to the desired initial state. For example, creates class under test, initialize its internal state, initialize properties, inject dependencies, and so on. Second phase is an exercise phase. During this phase, test runner invokes the system under test. For example, call the method of the system under test. Third phase is verify. During this phase, test runner make an assertion about the invocation outcome and the state of the system under test. For example, verify the return value and a state of the class under test. Last one phase is tear down, and ordinarily during this phase, test runner cleans up the test fixture. For many tests, this phase is omitted, but some types of tests, for example, database test, will, for example, roll back a transaction initiated during the setup phase. Okay, my main complication in testing is that system under test ordinarily has dependencies. The trouble with dependencies is that make tests slow and complicated. For example, let's take a look and what if I see and have, for example, order controller that uses order service that relies on order data access object, and order data access object provides access to the data that is stored in the order database. In the majority of cases, every layer is quite heavy and could take some time to be instantiated and initialized. But what if I'd like to test order controller in isolation? What exact instances I should create? Well, this is a complicated issue. However, there is a way to resolve this issue. The solution is to replace dependencies of the system under test with test doubles. A test double is an object that simulates a behavior of a real dependency. There are two main types of test doubles, stubs and mocks. The terms stub and mock are often used interchangeably, although they have slightly different behavior. A stub is a test double that returns value to the to the system under test. However, a mock is a test double that also is used to verify that system under test was correctly invoked or invoke a dependency correctly. In the majority of cases, a mock is often also a stub. There are many different types of tests. Some tests, such as performance or usability tests, verify that applications satisfy some non-functional requirements. And during my speech, I'd like to focus on functional aspect of testing. And in common, there are 4 different types of tests, and like unit, integration, component, and end-to-end test. And as you may see, ordinarily they're grouped into the pyramid. And this abstraction show that it's better having as much as possible quick unit and integration tests that provide you with feedback very quickly, and it's better having a bit less slow, brittle, and costly component and end-to-end test. It's better have writing different kind of tests in order to be confident that your application is working as expected. The challenge here is that the execution time and complexity of a test increases with its scope. So the more scope, the higher it is on the pyramid. Also, the larger the scope of a test, the more moving parts it has and less reliable it becomes. Unreliable tests are almost as bad as no tests, because if you can't trust a test, you're likely to ignore the failure. Okay, I have shown a lot of slides and would like finally proceed to the code. So the application I will show today is a simple Spring Boot application. Well, this application uses a REST controller for external clients, and this controller uses post service that is an ordinary Spring Bean, and it has a few dependencies, and main dependency here is a post repository. Post repository is a simple repository that is implemented using Spring Data JPA. And the first unit I'd like to test is a post service. As you may see, it is in the middle. And ordinary service has the majority of business logic of the application. So it's a good idea to start testing. In order to start testing this unit, I'd like to write a test, and this test will be extended with Spring extension. And second important part is a context configuration for my test. As you may see, I'm injecting a dependency I'd like to test. And if it is necessary, also for my particular test, to replace one dependency that communicates to database with a mockbean annotation. Actually, mockbean annotation is a very useful thing because it allows replacing a bean that should be registered in the application context with another bean, which is created using Mockito testing framework. And also it allows perform all the same checks that you can perform using ordinary Mockito classes. Okay, so if we're speaking about Spring, in the majority of cases, we are talking about application context. If we can create an application context for an ordinary application, it is also possible to configure application context for your test execution, and it could be done using the context configuration annotation. First of all, it allows to highlight what places should be used to find bean definitions. Of course, it's possible load bean definitions from resources, and it is necessary to use locations in this case, but also you could enumerate beans to be included into application context uses classes property. So here you can enumerate beans to be included or configurations to be included. If you have an application context, it should be initialized. And also you can extend this point by adding a new application context initializer. For example, you'd like to inject additional properties into your code. It is also allowed. Well, Spring allows building context in a hierarchy. So if you'd like to inherit one test from another, it is also possible inherit a context. And at the same time, it's possible to reject this functionality by using inherit location and initializer properties. Well, if you have a complicated bin definitions, or for example, generated dynamically, or for example, stored in the database, if you'd like to use your personal context loader, you also could use it for test as well. And of course, it's possible using uh, a name and provide a name for every testing, for every layer of hierarchy. JUnit 5 make a significant step forward and allowed building extensions. So using JUnit 5, it's possible to replace two annotations with one single annotation, Spring JUnit config or Spring JUnit web config. The same improvement, or maybe even bigger, Spring Boot bring to the Spring framework. This is actually amazing. I think it's an amazing opportunity to have your application bootstrapped quickly without necessity to write a lot of configurations, because Spring Boot after configuration provides with good defaults, and you could just focus on the logic on your value of your application. And also, it's possible using Spring Boot for writing your test and for configuring your application context. It could be done using Spring Boot test annotation. Let me provide a short description how it works and how it finds beans to be included into the application context. If you have a class that is annotated with Spring Boot test annotation, your test runner will go from the bottom to the top of your class packages hierarchy until it finds a class that is annotated with Spring Boot application or Spring Boot configuration annotations. Actually, these two annotations are meta annotations, and they have a few annotations on them. First of all, it is enable after configuration annotation, and secondly, it is component scan annotation. Using component scan, test runner scans class path once again, but from the top to the bottom, and looks for classes that are annotated with components annotations, and also Spring Boot configuration, or test configuration annotation. As a result, all the classes that are available for the ordinary Spring Boot application will be also available in your test. Okay, so let's take a look and see how it could be used. Let's assume that I'd like to test my application end to end, and because it is a Spring Boot application, I'd like to start it as a Spring Boot application, but from my test. So, as you may see, my application has a post controller that has a few endpoint, post and get endpoints, and within my test, I'd like to start my application on a random port, because actually I have a few tests that are run in parallel, for example, on my continuous integration environment. And for testing, I will use test REST template. It is a special extension for ordinary REST template that allows communicating with underlying Spring Boot application. So as you may see, during my test, I'm sending a post request to the application to create an entity, and sending also a get request to get all the saved entities. So as you may see, it works, and it works gracefully. If I have a blog application, I'd like to have a statistics in the majority of cases. For example, understand what posts are the most popular. It could be implemented really easily using Spring AOP, using a simple aspect that will intercept a request to my service and count what posts are the most popular. As you may see, what I have here, I have my post service, and IntelliJ highlights that there is an aspect somewhere near find one method. Aspect is a simple Spring bean which is executed before the with an advice that is executed before the find one method, and it works really simple and straightforward. It stores statistics in the hash map. And there is a method called getVisits that provides statistics regarding a particular post. And of course, returns null, 0 if it is not available. So I'd like to test this behavior using my Spring test. I'm injecting necessary dependencies. And here I have a really interesting situation. If I'm testing one single post, it also affects the application context because statistics is saved inside the application context. And I'd like to have a new application context for every test. I could do it using Dirty's context annotation. This annotation said that this test change the state of the application context, and it's necessary recreating it before running the next test. It is not a very good practice using Dirty's context annotation because in the majority of cases, it increases time that is required to run your tests. But if you cannot avoid it, you have no choice. Okay, so let's proceed to the capabilities that Spring provides for testing further. So if I have a clients, I have to convert data that I'm sending to them using JSON or Jackson. And first of all, I'd like to check whether my serialization and deserialization is working as expected. It could be done using this testing layer could be configured using JSON test annotation. As you may see, it configures a few of the configurations and include necessary bins into your application context. So let's take a look and see how it works. Actually, it works really simple and straightforward. I will test my post controller. As you may see, it has a few mappings and deal with post DTO. So I'm configuring my test using JSON test annotation and injection Jackson or JSON tester as a component for testing. So what it allows me to do, actually, this is a very smart component that allows checking that serialization is working as expected. So my JSON serialized text has a necessary path and path has necessary values. It is also possible checking that it works in opposite direction also gracefully. It also could be done using deserialization approach when Jackson or JSON tester read some JSON from resource and convert them back to the Java object. If I have a controller, I have to test it in the majority of cases end to end. And it also could be done using after configuration that is provided by Spring with WebMVC test annotation. It configures actually a lot, but it is really easy to use it. So I'd like to test how my controller is working end to end. I'm configuring application context with WebMVC test annotation and injecting mockMVC component into my test. This is a really smart component because it allows sending requests to the underlying application if it is really executing under the hood. And in this case, as you may see, I'm configuring dependencies and using mockMVC sending a GET request to a particular endpoint. And here I'm checking that response has a proper status, proper content type, and JSON in the response body has necessary values. Isn't it amazing? I think so. Well, if you're a smart cookie, if you're a hipster, you're dealing with modern application that have a single page, for example, front end built with Angular. But what if you are dealing with legacy application or the application that uses server-side rendering? Could you test it? Of course you could. So let's take a look how it is simple. I have an admin controller, which is a simple Spring MVC controller that deals with model and view. And this model and view returns, adds a few objects to the data model. And here, as you may see, I'm also using WebMVC test for checking how the underlying application works. So I'm injecting mock MVC, configuring necessary dependencies, and also here I'm sending a request. But in this case, I'm checking that, again, response has necessary status, view is as expected, and model has necessary attributes and values. You may say that in this case we are not checking rendering, but it is also could be done using HTML unit that is perfectly integrated with Spring Framework. In order to access it, you need to inject web client component into your test class. So using web client, I'm getting a page as an HTML page and can get any element I'd like and check its content. Well, I can test rendering as well. So that's great. If you have Spring Data JPA, it provides you with a lot of amazing capabilities like generating queries based on method names. And this is perfect, but has a lot of magic under the hood. And in order to check that it is working correctly, it's better testing it, of course. And it also could be done easily using data JPA test annotation. So I'm testing my post repository, which is a simple JPA repository. What I'd like to do for it. So I'm writing test, putting data JPA annotation on the top of it, and injecting the repository as well as test entity manager. Test entity manager is a special component that is automatically configured by Spring Framework that allow dealing with underlying database. And there is actually one single limitation, that underlying database is H2 in memory database. However, if you're using features of the JPA, there should not be any difference what kind of database you're using. But later I will show how to overcome this limitation. Also, in not all the situations allows you using Spring Data JPA. In some cases, you'd like to access your data directly using plain SQL queries. It also could be tested using JDBC test annotation. So, as you may see, it configures flyway, data source, JDBC template, transaction, and of course, underlying database. So let's take a look how it works. Let's assume I have a posts table that is actually accessed by entity, but still that has a few columns: post ID, post title, and post content. And I have a test, and during this test I will load records from to this database using a simple SQL query. SQL queries are executed automatically because I put a SQL annotation on the top of my test. And what I'm doing here, I'm adding a few records to the underlying database and accessing them using JDBC template and plain SQL query. So as you may see, it of course works, because everything that is written with Spring should work as expected. But again, this approach uses H2 database, that it is not great if you use some custom capabilities or native query in your native capabilities of your database in your queries. So mock or in-memory database is not always enough. However, we have Docker. Docker is an amazing feature and amazing tooling that allows you to run everything you'd like in the Docker container. If you'd like to have a database or message queue or even a browser or even anything else what you can run in the Docker, you could use it in your tests. Of course, I will show how to use it together with the Spring framework. Okay, so I'd like to test my post service, but with a real underlying database. So I have a repository, so I can access database using this repository. But here I'd like to use test container as well. Test container will automatically start the Docker container with a real database. It will be my SQL database. It will start it under the hood. However, I should provide some information to the Spring application, and it could be done using method that is annotated with dynamic property source annotation. So this method allows me to get access to the registry and provide underlying application with data source URL, username, password, and so on. So it allows to build a communication between the container you have started and the application that is under test right now. Well, if you write in an application, it will definitely communicate with other applications as well. For example, it is a very popular way of communicating with external application using REST API. So your application exposes some API using REST controllers, but also it could consume API of some external applications. This communication also should be tested because it definitely increases reliability. So for testing with external dependencies, you could use REST client test annotation to configure a test layer that allows testing of communication with external systems. So let's take a look and see how it works. Let's assume I have a post importer component that sends a request to some external endpoint using a simple REST template. REST template, as you may see, sending a post request of import request and expects to get an import response as a response from server. And if I'd like to test this external communication, I will configure my application context to run mock REST service for me. This REST service will play a role of an external dependency. And here I'm configuring that my external dependency uh, should deal with another endpoint. And also I'm injecting mock REST service component. It will be configured in a few lines. Here I'm also injecting the response that this mock server will provide. And actually here I'm writing an expectation that in case of request to the importer endpoint, it is necessary to send back a response of the application type JSON with success code and a given payload. So when mock server is configured, I can test my component in the same way if it is connected to the real external application. Well, so as you may see, Spring provides you with everything you'd like to have to make your application reliable. Well, unfortunately, my speech is almost over, and this is all I wanted to show to you today. The main outcomes of my speech are the following. First of all, follow the test pyramid approach because it allows you to build a reliable test base that will provide you with a feedback quicker. The main advantage of quick tests that you could run them on your own machine and get feedback maybe in a few seconds or maybe in a minute. But if you have only end-to-end tests that should be executed on a continuous integration server, before that you have to build and deploy your application. Next, run until test runner is available and so on. So it will take time and you will get a feedback significantly later. Of course, know the tooling that you're using. Spring Framework is amazing technology and amazing framework for building application. It also allows testing because it provides number of tooling and number of helpers for testing of the application. If you'd like to write a quick test, follow the first acronym. Your test should be fast, independent, repeatable, self-checking, and timely. That's great. In order to make your code testable, follow the solid principle because it is a very simple, but it allows and provides you a lot. Okay, all the examples I've shown today are available on my GitHub, so you may see a link. And also here I'm putting 2 links to the documentation of the Spring, and additional details could be found there. So thank you very much for joining my session. And actually, let's join Q&A session in a minute on a Hopin platform. Thank you very much. You spent this half an hour together with me. Bye.